everybody to this demo on a course. We call this course Site Reliability Engineering and Cloud Performance Engineering in DevOps. Um, so we will talk about this course, what it covers, and how do we go about it. Before we start, let me ask you, all of you, a question, and let me introduce myself, friends. My name is Roshan Kumar. I am with Isha from last 5 years. Been a trainer here. I'm also take training with multiple institutes, other institutes like Intellipath, Edureka as well. I have a overall 16 years experience, more than 16 now, and I'm working currently as a principal SRE, principal satellite engineering with one of the reputed giants of the world. I have multiple cloud experiences. I'm a solution architect certified with AWS, Azure, GCP. I started my career as a Java developer. Then I have been into various other SUS. I have been into sysadmin. I have been into DevOps. I'm currently working as a principal SRE. That's background about me, friends. So we will start with a. So this is the agenda. We'll start with a question, and then we will understand basically the software development and deployment evolution, how the software has been developed and deployed over the years. And then we'll talk about the course and how do we go about this course. And then we'll take Q&A at the end, friends. So, okay, this is the question. Do you think, friends, are performance engineers, or I would say anybody nowadays, in anybody working in IT, in current market trend, current scenario, do you think, based on experience, that we should know these things? DevOps, microservices, containers, and cloud. How many of you agree that yes, we need to know this? You can use the chat option. You can unmute yourself, anything the way you feel comfortable. Please confirm, friends, based on your experience working in IT. Okay, I have started to
Yeah,
get
we need to know about the cloud and the DevOps and all this.
right. So Hari and Mohan agrees. Right. It is good. Yes, Kiran, perfect. Mr. Reddy also agrees to this. Absolutely, friends. See, these things are mandatory. If you are a performance engineer or anybody or a cloud engineer or anybody in IT, except I would say the QA folks may not need to know that, like the functional tester I'm talking about, they may not know, may not need to know the underlying architecture, underlying infra. They are only concerned about the functionality of the application, except those folks. Everybody, developer, DevOps, SRE engineers, performance engineers, cloud engineer, admin guys, everybody across IT, they need to all this. And why do we need to know all these things only? DevOps, microservices, containers, and cloud. When you see the next slide, the software development and deployment evolutions, how the software has been developed and deployed over the years, you will understand this, why these things are only important and, or I would say the relevant, right? So let me show you the software development and deployment evolutions, friends, over the years. If you look at this slide talks about the journey, how the software has been developed and deployed over the years, the evolution. So if you look at the development process, we started with waterfall. We started with waterfall model where we developed everything at once. Whatever the planning was there, we developed everything at once, and then we started to test it. It had a lot of flaws. It was very difficult to, if let's say at the end, because we were testing at the end, very end, after we developed the complete software, at the end we were when we started to test, in case of let's say flaws like architectural flaws, the application is not scalable. It was so difficult to go back and make changes. The requirements may change, but we're not taking the requirements in middle and we would to get the requirements after at the end. Okay, no, we should also have that. It was very difficult to go back and make those changes in the waterfall. We learned from our mistakes. Then we shifted to agile, where we did the development into phases. We call those sprints. It has also a lot of advantages, as no problem as the process perspective, but we had the process of manual intervention. When the code was ready, it took a lot of time for us to deploy the code to production. Every steps, the building the code, testing, QA, functional testing, performance testing, security testing, that took a lot of time because there was a lot of manual process involved. There was not much automation. So that's where we talk about the DevOps, where the process is same, the agile, the way of development into phases, sprints. We took the feedback from the previous sprint. We we always went to the customer and took the feedback, and we incorporated all those things, and we bring in automation here so that when the code is ready and the time you release the code to production, that can be done swiftly. And that's what DevOps focuses on. So if you look at the evolution, we have been evolved from waterfall to agile to DevOps. Same thing happens for the application architecture. Earlier, we were working on the monolithic applications. If you look at the trend now, we are all talking about microservices because we all know, understand the importance of microservices. If we have microservices, the application reliability, availability could be increased. Because here in monolithic, the entire code base was together. The entire code base was together. Issue with one of the issues with one of the modules could impact the other modules. That's why we talk about microservices. And the two microservices can communicate using the REST API calls. We'll make it independent. Each microservice is an independent application and they can communicate using APIs. We are developing all the newer developments is happening in the microservices domain. Okay, coming to the infrastructure. Earlier, when around 1980s, we were deploying things on the physical server, directly on the physical server. We were wasting a lot of resources. Then there came a technology called virtualization. It was a great revolution. We could use the same infra and we could create multiple VMs after virtualization. And we could install multiple applications in each of the VMs. Now in 2015, 10 years back, we found a technology called containerization that can even further optimize the infra utilization. We could create containers, and that's where you talk about Docker and Kubernetes. Because nowadays, if it comes about the deployment, we're deploying the microservices on the containers. In the containers, we're talking about Docker. We install Docker in the VM and we could containerize the VM and we create containers. We have the pods in the Kubernetes. We have auto scaling, auto healing. All those features of container orchestration engine Kubernetes makes it so life so easy, stable in production. And then it comes to the infrastructure application. Where do we host it? It was earlier the data center. There was no other option back in 1980s. If you had a business idea, we have to set up a data center, which is a very costly affair, very, very costly affair. Setting up a data center is not that efficient. You have to procure the land, construct the building, purchase everything, hardware, set up cooling mechanism. You have to have redundant power sources, internet connectivity, everything. It was a very huge, costly affair. Only the big players could afford to have a data center. But if you look at the situation now, we are in the cloud. And if you need a server, just go to AWS, Azure. We have so many cloud providers. Just go there and get some servers. And it's easy to pay monthly bill of $5,000 or $10,000 compared to billions of dollars of investment in a data center. So this is where the current market trend, and it's going on, friends. And if we don't know these things, we would not be up to the market and we would be missing out on a lot of things. DevOps, microservices, containers, and cloud. So considering this aspect, this course, we are coming up with the course, Cloud Performance Engineering in DevOps and SRE. Considering these aspects. Now, this is the course syllabus. We talk about a lot of things here. This is a very vast course. We take, though it's a vast course, but we take it from scratch. We don't expect a lot of prerequisite knowledge. If you have a basics of IT knowledge, irrespective of any domain that you are, if you are a performance tester engineer, cloud engineer, automation engineer, production support, anybody across. If you understand the basics of IT, if you understand what is a server, what is a port, that's all we require to take this up. And we cover a lot of things. And we have approximately 50 hours of live sessions, 45 to 50 hours of live sessions. This course goes around more than 2.5 months, around 3 months. And we cover a lot of things from very basics. We cover cloud. We take up AWS in this course. We take up Linux because the 95 to 98% of the deployment that's happening in enterprise industry is happening on Linux server. Yes. So Hari, if you're a project manager and let's say, think about it, Hari, if you do not know about this technology, but your project needs to are aware, or let's say your project is working on this technology, then how would you be able to manage, Hari? So absolutely yes. Being a project manager, being a team lead, when you are working on this setup, the DevOps, the cloud, the microservices setup, you have to know all these things. Then only you can manage your team well.
Thank you.
We talk about Linux because the enterprise, what I have understood over the years from my experience, from my teaching experience, that people are comfortable with Windows because they use Windows, it's a UI, graphical user interface, comfortable. But whenever I talk about Linux, we are struggling. That's why we have this course of Linux here, where my tagline is get as comfortable in Linux as you are with Windows. It's all about the operating system. We just need to know how do we operate it. How do we work upon it? Because this is important. Let's say tomorrow somebody wants you to check the logs. Later you have got the Linux server access. They want you to check the logs. How would you go and check the logs? How would you SSH? How would you, what command will you issue? Let's say you have got the access of the Linux server. Somebody wants to check what is the CPU memory usage. What are the different processes running? Where is the bottleneck? How would you do that? We should know, we should be comfortable with Linux. And that's what we are talking about, the Linux. We'll talk about the software architecture, the monolithic applications, microservices, how they are differ, why we talk about microservices so much, why they are so much, they bring it reliability into picture. We'll talk about that. We talk about containerization. We talk about Docker in this course. We talk about Kubernetes, the most important topic nowadays, because the entire nowadays, if you look at this, friends, you can check. I can ask you as well about what you work upon in your company. But it's if you are using containerization, it has to be Kubernetes because Kubernetes offers you so much of stability of the features. Kubernetes from Google. Who handles load traffic better than Google? We talk about performance engineering in DevOps. We also share Java performance engineering, various concepts of Java performance engineering in this course. First of all, how performance engineering fits in DevOps. What is DevOps? What is CI/CD pipeline? That is the buzz about what it is. How do we create pipeline? How can we make sure when the code is ready, you have a pipeline and an automated process which will get triggered one after the another, and eventually my code will get deployed to production. What is that process? Automated process, which where we are avoiding or we're not doing the manual activities. Everything is automated. When the code is ready, what do we expect? What is the end goal? When the code is ready, our end goal is to deploy that code to production. That is our end goal. but we do a lot of steps in between. We do quality checks, functional testing, performance testing, security testing. We build the code first. We deploy the code to QA environment, pre-prod environment, prod environment. We do the building the code, we deploy the code, and we test the code. There are so many activities that are involved. But if we do this manually, it takes months. But the code was ready a month back, and you're deploying the code to production after a month. It doesn't make sense. Why can't we automate this? Why can't we automate the functional testing using Selenium? Why can't we automate the performance testing using Jmeter? And when the functional testing completes, trigger the Jmeter job. And we need a CI tool. We integrate with Jenkins. Why can't we automate the security testing? So we'll talk about that in DevOps, right? And how performance engineering fits in DevOps. We'll talk about Java performance engineering in this course. What is Java, JVM architecture, various memory spaces that we have, heap, we have PC registers, we have method area, we have how JVM works, how Java manages the memory. We have garbage collection, various GC algorithms, heap dump, thread dump, GC log analysis. We talk about that in this course. We talk about automation, and that's required for a SRE engineer. We talk about Terraform and Ansible. Terraform, let me ask you a simple question, what it is in a very simple term. We have companies like, let's say, banking application. We have HDFC, SBI, ICICI. We have so many applications around Flipkart and various kinds of application. We have so many servers deployed in the production because there's so much of workload is there, so much features are there, so much of load is there. Do you think those companies are provisioning the servers manually, creating the infrastructure manually, where they have 500 servers? They have so much of complex architecture. We have web server, app server, database server. Do you think those things are getting created manually? No, we use automation. Automation is the key to become success in this current market trend. Wherever, whichever skill you are, you have to know the automation. To Terraform and Ansible, we talk about this. We talk about observability in this course. We talk about Prometheus, Grafana, Elastic Stack, and we talk about SRE concepts. What is SLO, SLA, SLIs, error budgets, disaster recovery. So we cover a lot of things. I'll go in detail about the course, friends. Any questions before I go in detail about the course? I'll share a link with all of you. You can find detailed syllabus here. So this course we are coming up with in the weekdays, morning time, IST. We will meet 3 days a week, mostly Monday. Today is Monday, IST. We'll meet from 7:30 to 9 a.m. 1.5 hours. Monday, Wednesday, and Friday, 3 days a week. If we need, we can have a 4 days also, but let's plan for 3 days in the beginning, and we will decide based on how we need. So we are going to meet for 3 days a week, Monday, Wednesday, and Friday, so that you get enough time for practice as well, because we do hands-on. Everything is hands-on here. And you take approximately 2.5 months to 3 months to complete this course, because we have a lot of topics to cover, as you would have observed. So we are going to meet, friends, at this time, Monday, Wednesday, and Friday, 7:30 a.m. to 9 a.m. IST. Look at the course syllabus. Yeah, go ahead. Can you repeat your question, please? Is there any same courses there on the weekends also? Yes, weekends we have a batch. There are 2 batches we run in the weekends. In the night, 7:30 p.m. to 9:30 p.m. The course I'm about to complete the course there. It would take 4 more weekends, 3 more weekends to complete the course. Approx 70% of the course is complete there, so I take up the course as well. And we have at 11 a.m. also IST, 7:30 p.m. and one is 11 a.m. 11 a.m. we have just started. I would say 30% of the batch is complete. Course syllabus. Every Saturday and Sunday. Saturday and Sunday. That's right. Weekends. No, no, we have not 30%. Okay, let me. I think I was. Okay, there are two batches that we run over the weekends. Okay, there are 7:30. One is 7:30 p.m. IST I'm talking about, and one is 11 a.m. IST. So this is 70% complete, and it will take 3 more weekends to complete this. We can start after the 3 more weekends, and this 11 a.m. is 30% complete. Okay, it would take approximately 1.5 months to 2 months to complete. Approximately. So there are two batches over the weekend, Saturday, Sunday we are taking up. We also have a batch in the weekdays evening time, 3 days a week, Tuesday, Wednesday, and Thursday, from 8:30 to 10 p.m. There are some couple of batches that goes on. So we have this over the weekdays, 3 days a week, Tuesday. How much it is started or it is not? No, no, we are at the same level here. This is also 70% complete. So this is also going to get over soon. So it will take another, I would say, 3 more weeks to complete this. This is also 70% complete. This course is the same as your earlier course. Right, right. It's the same SRE we are talking about, the same course that we're talking about, all the 3 batches. So I'm coming up with the 4th. Go ahead. I thought it is this for cloud. This is the same course. Cloud performance engineering in DevOps. Cloud is one of the part of it. It's a subset. Cloud is a subset of this bigger course. What is the question? Could you be clear, Prashant? No, I thought this lecture, this course is only for cloud. No, no, no. Same SRE. Cloud. I just mentioned about all the course topics, right? It's not the cloud part. Okay, so we have options to select, but it will take some time. We are coming with a new batch now, like 7:30 a.m. now, weekdays. This is a new batch, friends, and it will be over Monday, Wednesday, and Friday. Hari, you're not audible. Can you try Hari again? Hari, I see you are muted. Am I audible to all of you?
Yes.
Yes. Okay. Okay. So Hari, you're able to speak, right? I think different Hari is trying to speak then. Okay.
Yeah, this is different Hari. This is Hari Babu, and
Okay.
the other person is Hari.
Okay. Sure. Thank you. So this is a new batch. Okay, 7:30 to 9 a.m. 3 days a week, Monday, Wednesday, and Friday. We're coming up with this over the weekdays. Okay, that's the new batch. This is the batch we're talking about. Okay, friends, let's talk about the course now. So we have AWS, as I told you. We're gonna start with this, right? That's how we start with AWS, because that's very fundamental thing. We should know what is cloud, how do we create server, storage. We manage the users using IAM and various load balancing, auto scaling group, lot of things. Okay, you can go over the detail. Okay, I'll share this link with you. I don't want to overwhelm you right now by just keeping the topic names. Just know that, friends, you are very much covered here. Covered to a level that you can also go for the solution architect associate exam with upon few guidance. I'll guide you. This is going to be the fundamental, the foundation for the solution architect at the architect level is what we cover in depth. And we talk about reliability, performance, cost, every aspect. It's not just about the service. any cloud. We focus on the performance, reliability, cost, security, every aspect here. Okay. Now, friends, the Linux part. That's what we cover. The Linux. That's very important. I'll also share what do we share as part of the. Let me show you the PPTs that we have so that you understand the depth of the topics, each of the topics. So I'm showing you the one of the all the documents that I share with everybody who joins, right? So if you look at this, the cloud part, friends, we have approximately in detail, if you see this, this is for the reference and how we topics we cover. If you talk about this, we cover approximately 200 slides, 150, 200 slides here. In detail, we cover. Lot of services we cover. As you can see here, we cover approximately 150 slides, 170 slides. We have it here. And we cover about a lot of things. Lot of things. Okay, in the cloud perspective. Coming to the Linux part, again, we cover it from scratch. You do not need to have a lot of knowledge. If you know, even if you do not know how to create a server, how do we SSH, I'm going to give you a platform to practice the Linux commands. And we talk about from very scratch. How do you navigate directories, CD command? How do you get system information? How do you install things? How do you manage the permissions of a file? How do you change the ownership of a file? How do you uh, search for a text or the replace a word in the text? Every detail, as you can see here, process management, networking, disk usage, and eventually at the end, the shell scripting. How do you do shell scripting for performance monitoring? So we talk about so much of things here in this course, right? In the cloud, the Linux part. Then we have the reliability, the architecture part. I'll go in the sequence the way we will go about it. So we have the monolithic and the microservice architecture. How do we, what is monolithic? What is microservices? How they are different? Then we talk about Docker. So again, if you see this, we have the Docker, the container engine. It is required. This is what virtualize the VM, and we containerize the VM and we create containers. So we talk about the same thing. What is monolithic? What is microservices? The architecture of microservices, how it is. How do we create containers? Various aspects of it. The Docker architecture and various commands that we have when to operate with containers. We talk about that. And then once we understand the container part, we'll talk about the Kubernetes. That's the most important thing, because we need to have understanding of container. Then only we can learn the Kubernetes part. And we do hands-on here. We create the cluster, real cluster in EKS, in AWS. We create the cluster. I'll demonstrate everything. Again, it takes this Kubernetes is a very vast topic, and we covers a lot of things here because I know the importance of this Kubernetes, and we have approximately 100 slides here, as you can see here. We talk about ingress. We talk about horizontal pod auto scaling, cluster auto scaling. If you know about these topics, very important topics, these things are to understand how the routing works in the case of containerization. In the case of VM, we talk about auto scaling and the load balancer in the case of VM. But in the case of containers, how the routing works, we talk about in the Kubernetes. Then we talk about DevOps, Docker and Kubernetes part. Then we talk about DevOps here, how performance engineering fits in DevOps. CI/CD pipeline, how do we create such things? We cover about that. So we go to the SRE module here and we talk about the DevOps part. How do we create pipeline? So we are going to create this pipeline is hands-on, using this Jenkins. We're going to have such pipeline created. As I'm showing you here, we're going to have this pipeline created. We'll have a code in GitHub. We'll take the code, we'll build the code. It will be an automated process. As soon as the developer uploads the code to GitHub, all these pipelines would trigger one after the another. And that's what we understand. Because when you work in the company, they will expect you, if you're a performance engineer, they will expect you to come with the performance job using Jmeter or LoadRunner. How would you create that? Because it's you who are going to create that. DevOps engineer is going to integrate with you, going to take your job and integrate in the main pipeline. But it's you who have to create the Jenkins Jmeter job, integrating with Jenkins. So we'll talk about that. How do you send emails when a job gets triggered? It says this job fails, Jmeter job has failed. How will you notify the performance engineer? How do you get notified? So we'll also send the notification things, right? So again, we talk about the pipeline using AWS services as well. We have AWS services using code commit, code build, code deploy. We talk about AWS services as well. Okay, friends. So I don't want to overwhelm you just by the topics. Just if you're able to understand, it's good, friends. We talk about observability, the monitoring part. How do you analyze? How do you create, set up monitoring tools like Prometheus and Grafana and Elastic Stack? We talk about Java performance engineering. We have again the Java performance engineering. We cover a lot of things here in the Java performance engineering. The GC algorithm, heap dump, thread dump. It is very important for the troubleshooting perspective. Various GC algorithm, the JVM architecture, how a Java executes this program, the JVM architecture, various memories that we have, method area, heap area that we have, how GCs, how JVMs work, the various GC algorithms that we have. We have JVM, how the JVM heap, how the JVM looks like. We have the Java heap, we have the meta space, and how they work, various GC algorithm, GC, parallel GC, CMS, G1 GC, how it works. And then we will understand about the shallow heap, retained heap, heap dump, thread dump analysis, hands-on we cover as part of this course. This will help you the troubleshooting. And then we talk about the automation. We'll talk about the Terraform, Ansible. Right? And the SRE module at the end. The SRE part. What is disaster recovery? What is a DR setup? What is blue-green deployment? How a company needs to handle the disaster recovery? Why do they require to have a DR setup? Right? So friends, everything we do cover. And that's why we have split this. This is a very vast course. So we have split this into the live sessions as well as the recorded sessions. There are two recorded sessions which we share as part of the course. The Linux part is going to be the recorded session. My recorded session, I earlier used to take it, but the course was getting even lengthier, 4 months, 5 months. So we have split this in a way that we complete the course in 3 months. So, and you can ask me questions. My recorded sessions, we cover this Linux part and the Java performance engineering part. So these two part is going to be the recorded sessions, my recorded sessions. So earlier we used to take it up. So that what people have asked that, Rasan, could we, when you're talking about cloud, can we get this recording? So yes, you can get the recordings and you can learn in parallel and you can ask questions, any doubts that you have, because the recordings are also very quite easy to understand. And we do the live session on the cloud, Docker, Kubernetes, Jenkins, observability, SREs, DevOps, and we focus on these things. And in parallel, you're supposed to. So only these two are recorded sessions. Linux and Java performance engineering, and everything is with what we do the hands-on. As part of this course, we are also bundling the core Java, because if you are a performance engineer, you want to learn Java, having understanding of code is important. That will help you become a better Java performance engineer. We cover the we do say it's not going to be the my recorded sessions. We do cover the core Java part and the Python. we're looking become an SRE engineer, we should also know how do we automate using Python scripting. So this is about the course, friend. Entire thing about the course. Okay, we cover a lot of things here. Somebody at very good at Isha, they cover this up. We have integrated with that. We have taken that up from them, and it's quite worth. I have personally checked it. So this is the entire course. That is how we go about it. Friends, any questions on this? Feel free to ask any questions if you have. It's a complete hands-on course. I'm gonna show you do things. It's not going to be just theoretical. 20% is theory, which you need to understand, and 80% is hands-on. I'm gonna show you how things are. Right from the cloud perspective, how do you create the server? How do we SSH? How do we install something? What are different services? Storage, load balancing, auto scaling group. Everything is hands-on. Yes, friends, anybody has any question, feel free to ask.
Yeah, so to become the SRE, you definitely require some coding knowledge, right?
Which knowledge, Mohan?
I mean, scripting knowledge or the
Absolutely,
coding.
absolutely. Automation, exactly. So that is why we cover on the two scripting here. I cover the cell scripting part, which can also use, and then we have the Python scripting knowledge. So you can skip the Java part. You can focus on the Python scripting part. You can be a Python because that's where more for the automation perspective, we do use the Python. And I do share the one of the commonly used uh, the Python scripts for the automation. I do share that as part of the course. If you look at that from the eliminating toil, we have the Ansible, we cover the Terraform, and I do cover the Python scripting. One of the very useful, the common useful automation things using Python. I do cover, share the scripts here. But if you have the Python knowledge in general, that will help you. And that's why we have the Python course. We do give that a bundle, the recorded session with this course. Yes, scripting is important. To become an SRE engineer, you have very asked a very good question. To become an SRE engineer, we need to know cloud. Okay, we need to know Linux, the Docker, whatever we are covering in this course. This course is very much in line. We need to cover container technology, Docker and Kubernetes. We need to know the DevOps part. Apart from that, the observability. You should be very much comfortable with monitoring tools, setting up alerts. You should be understanding the troubleshooting part. If you have, because SRE is all about working in production. That is the difference between an SRE engineer and a performance engineer. They are very much in line. They share a lot of skill sets in common, but the prime difference, the most significant difference that a performance engineer works in low environment, QA2 pre-prod, whereas the SRE engineer take care in the production environment. If the issues happening in production, how will you troubleshoot it? Because you don't have a lot of time. You work under the pressure because it's prod. In low environment, we can delay. Okay, we'll see this tomorrow. But it cannot happen in prod. You need to find the right solution there itself. That is the main difference. So the troubleshooting at its peak. Now, troubleshooting could be from the Java application perspective. That's why we have the Java course. Now, troubleshooting could be from the infrastructure perspective. That's why we have the cloud course. So it could be infrastructure perspective. It could be from the Docker, from the containers perspective. The problem could be from anywhere, right? So we need to be very good at troubleshooting, and that's why we have all these things covered. You need to understand the security part. How do you secure the application? We cover a lot of things from the security, cloud security. We cover security group. We have NACL. We have public subnet, private subnet. We have a lot of services from the security perspective. We cover IAM. And at last, the automation. We should be very good at automation. And that's where we have the cell scripting covered. The Python scripting is what we recommend. We share scripts with you, share the recorded session, and that's how we go about it, becoming an SRE engineer. That's why it's so vast course. That's why it is such a vast course, because we have to cover, we have to know all these things. It's a prerequisite. Yeah. Anybody else? Any questions? See, the day you enroll, I'll share the plan, how we are planning this. The day you enroll, we give you the Linux session. Okay. We give the day you enroll, we give you the Linux. It's the recorded session, as I told you, my recorded session. You can start to go over it and you can ask the questions in the live sessions. We talk about the cloud. We get you the platform. Where do you practice the Linux sessions, Linux commands? We create the server and we talk about the cloud. This takes approximately a month, cloud, because we cover in detail. This takes approximately 15 hours of the course because we cover in detail. Upon we cover the cloud part, we talk about microservices and monolithic and microservices. We cover this. What is that? And then with the Docker and Kubernetes we follow. When we complete the Docker and Kubernetes, I share you, if you ask me, I share the Java performance engineering here. Because I want you to full focus till this time. I want you to full focus on these things. We cover the Java performance engineering course. Then you can go over it and ask me questions. And then we start the observability here. We start the observability journey here. We talk about Prometheus and Grafana. We talk about Elastic Stack. The two topics we cover here, Prometheus and Grafana, and Elastic Stack. Open source. Now, you can ask, why don't we cover Dynatrace? There are so many tools. Okay, we cover the open source, which is highly in demand, because a lot of companies, they are preferring the open source products nowadays because they don't want to invest in commercial tools. Dynatrace, AppDynamics, that's why we are focusing on the open source. We talk about observability, then we talk about the DevOps and SRE module. DevOps module. That's where this comes in. The troubleshooting part would come in here as part of this DevOps module. We talk about the SRE module. We talk about the databases, and security is a part of cloud. Okay. Security is a part of cloud. We cover that. And from the automation perspective, we do cover the shell scripting and the Python scripting. And we have Terraform and Ansible as well. It's part of this Terraform and Ansible from the automation perspective. And we talk about the SRE modules, various things. So this is how we plan the course. And that's why it takes so much of time. And that's why we have segregated it into the recorded session. This is going to be recorded session, as I told you. And this, but my recorded sessions. And you can ask me questions at any given point in time. That's how we take it up. This course. Completely hands-on, completely from scratch. Okay, I see a question. Do we need all these syllabus for SRE? Absolutely, yes, Hari. You need to know. That is what the site reliability engineering is all about. See, in SRE, we have various roles. Hari, understand this. We have L1, L2, L3. L1 are just production support. Those who monitor, they work in shift, they do the monitoring part. That's L1 engineers. We are talking about L2 engineers, which can troubleshoot things. And you require these skills to troubleshoot. We are trying to become L2 SRE engineers. L3 are subject matter expertise. Leave this. They are developers. You need to have a lot of experience to become L3. We're talking about L2 SRE engineer, not the L1, which can do the production support monitoring part. L2. Right? Okay, friends. Anybody else? Any questions? Okay, I take the silence that we're all good, friends. So we are going to start our journey and we're going to meet, friends, day after tomorrow now, as planned. We have started our course. So let's meet on Wednesday now and we'll start with the cloud. That's what we're going to start with, cloud. Get enrolled at the earliest so that you can get the Linux and the Java Performance Engineering recorded sessions. We'll share the Linux part first. And this is how the playlist would look like. Let me show you. You'll be getting all the recorded sessions like this. Like as the day, this is, let's say this is the last couple of, let me show you the latest one. I have batches going on. So let me show you the weekends batch. 1 second, friends. This is my, so these are the weekends batches going on. So as and when we complete this, you will be having a playlist like this, right? And you would be getting this kind of access, friends. This kind of playlist you'll be added to. These are the latest one that's going on over the weekends. So as and when we'll complete this, right, you would get this kind of recorded sessions. Like a first recording will be the one which you're recording right now will be uploaded here. That's our first recording. And slowly when we go over day 1, day 2, that's the demo session. And then we go over day 1, day 2, day 3. Whenever we complete this, it will be recorded here, updated here. As you can see here, we are approximately 29. Yesterday I completed the 30th one. The recorded is not uploaded here. Yesterday evening, that 30th, day 30 is, and then we have 30% of the course still pending. It will take 3 more weekends to complete that. So that is how the plan fits. We not just this, you also get the Linux, the Java as well in the same playlist. So you have, like, say, look at the Linux part, very simple, 3.5 hours of recorded sessions. You're gonna have it, everything, whatever you need to know. No hurry. For L1 support, you don't need to know all these things. As I told you, we're preparing for L2. L1 support, L1 requires the basics of Linux, the basics of cloud, the basics of monitoring, and that's it. L1 would be done. We're talking about L2 here, hurry. So this is what we covered in the Linux part. We have playlist for the Java performance engineering, as you can see here. This is what we'll be sharing. You have everything here. The JVM architecture to GC algorithms to shallow heap, retained heap, the heap dump, thread dump. We are talking about these things here. So this is going to be the playlist that, and you will have all these recordings with you, lifetime access, friends. So I'll be in a WhatsApp group with you, all time connected. You can ask me questions. How we will get L1 support training? This is what it is. So Hari, this is an L2 course. That's what I'm trying to tell you. We are not here to prepare about L1. This is the L2 training. I'm talking about a level up, right? If you're looking for L1, if you complete this course anyway, you'll become L1 and you move towards L2. Okay, friends. So I think we are done. I don't see anybody asking any questions. Feel free to ask me, approach me over the WhatsApp, friends. I have added there. You can, if you have technical questions, you can get in touch with Mr. Kumar and he can give me my number. I can talk to you as well. Okay. That's all, friends, for today demo. Thank you. And I hope you learned something. We'll meet on Wednesday with a day 1 agenda. Thank you so much, everybody.